Hi students, all of you welcome. Welcome to Sunil Engineering Academy. Students, from today onwards, we are going to practice RRB JE Electrical previous year questions. Let us start the session, guys. Coming to the first question, in shunt Zener diode voltage regulator circuit, the purpose of the resistor connected in series with the input voltage is dash. What is the purpose of series resistor? We know very well the Zener diode voltage regulator circuit. Here we have the supply voltage. Here we have the Zener diode. Generally, Zener diode connected in forward bias or reverse bias. It is connected as reverse bias to work as the voltage regulator. Here we have the load. Okay, so input voltage. Here we connect series resistor. What is the purpose of series resistor? Whenever we connect the resistor, then what is the primary purpose? It limits the current, it reduces the current. So it reduces the current flow through the Zener diode. So then Zener diode will be safe. Okay. Otherwise, there is a chance of damage of Zener diode. Okay. So here the primary purpose of this series resistor is to limit the current through Zener diode. Okay. Coming to the next question. In arc heating, the arc is sustained by dash. The arc is sustained by dash. This is a very easy question. Whenever we have the electrodes, if you apply high voltage, then what will happen? Because of the high voltage, then the air around the electrodes will be ionized. Air will be ionized. Correct? So, whenever the air is ionized, here plasma will be created that allows the electricity through it. Okay, so that means arc will be generated. That arc offers the low resistance, then current will be flow. Okay, so the arc is generated or sustained because of ionization of air. So answer is option 3, ionization of air. Coming to the next question. The difference between capacity factor and load factor represents dash. A very easy question. We know very well the definitions of load factor. As the name itself, load. So it is average load by maximum load. Okay. So here in the numerator and denominator both having the load only. That is a simple trick to remember. Load factor, average load by maximum load. In the same way, capacity factor. As the name itself, capacity na, so we need to give the respect to this capacity. So that's why in the formula, average load by, instead of maximum load here, capacity. That means installed capacity. Installed capacity. Okay. So here load factor, average load by maximum load, capacity factor, average load by installed capacity. So the difference between these two is nothing but we can say reserve capacity. Reserve capacity. Generally, we go with the higher installed capacity than the maximum load. So installed capacity minus maximum load or maximum demand. Okay, it is generally maintains the positive. Okay, generally maintains the positive. That means higher installed capacity than the maximum load. So the difference between capacity factor and load factor is nothing but reserve capacity. So what is the answer here? Answer is option 4. Coming to the next question. Which of the following is the characteristics of soft magnetic material? Soft magnetic material. So what it has? The characteristics of soft magnetic material. The first one, it has high hysteresis losses. No, it has generally low hysteresis loss. Low hysteresis loss. And the second one, it has low cohesivity. Yes, correct. Low cohesivity. What is meant by low cohesivity? It is nothing but It requires small external magnetic field to change their magnetization. So it requires small external magnetic field to change the magnetization. Magnetization is correct. And what about the next one? It is low coercivity. And what about relative permeability? It is high. Relative permeability is high. And what about absolute permeability? It is also, you can say, high only. High absolute permeability. Okay, so the answer here is low coercivity. Answer is option 2. So we need to learn all the characteristics of this soft magnetic materials. Okay, then we can easily give the answer for this. Coming to the next one, this type of questions are very easy, guys. Here read the given assertion and reason carefully and select the correct option. Option that is assertion. Weakening of springs in PMMC is due to aging and temperature. Yes, correct now. Weakening of springs may be happen due to aging effect and due to temperature. Correct. And coming to the reason, permanent magnets used in PMMC instruments tend to lose their strength over the time. Yes, correct. It is also correct. But is there any relation between these two? No, there is no relation. Both are individual statements. So, you can say A is correct, R is correct, but R may not be correct explanation of the A. So, we can say both A are true, but R is not the correct explanation of A. Okay, so the answer is option 2. Okay, coming to the next question. With reference to energy band diagram of NP and BZT, there exists dash phase charge regions and maximum band bending at dash junction. A very easy question, guys. Here they have given NPN transistor, NPN BZT. So NPN. Okay, so generally you can say it is a EBC phenomena, emitter, base, collector. Okay, so here we have EB junction, and here between these two CB junction. Okay, generally we connect EB junction as a forward bias now, and CB junction as reverse bias. Correct. Forward bias in the sense negative will be connected, negative, positive will be connected to positive. So it is a forward bias, and here reverse bias. Negative will be connected to positive, positive will be connected to negative. Okay, just wait. Okay, so now it is a forward bias, it is in the reverse bias. So how many space charge regions, that is how many junctions we have? EB junction, EB junction. We can also say that it is the JE junction, and it is the CB junction, CB junction, or you can say JC junction. So two junctions are there. So we can eliminate these three. Okay. And the next question, maximum band bending at dash junction. Generally at reverse bias, there is a chance of high depletion region. So that means high depletion region in the sense you can say maximum band bending. So at a collector junction, at a collector junction. So answer is 2 and base collector junction, that is CB junction. So answer is option D or option 4. Okay. So once again guys, here we have two junctions are there in the BZT, that is EB junction and CB junction. EB junction generally forward bias, CB junction generally reverse bias. So due to reverse bias, there is a chance of maximum band bending. Okay. The pi model or T model is commonly used to represent which type of transmission line? We know very well in a short transmission line, we go with the lumped model. Lumped model. Okay. And in case of medium, we have T model, or you can also say that that is the pi model. Okay, in long transmission method, we go with the rigorous method. Rigorous method. Okay, so the answer here is option A or option 1, medium transmission line. Coming to the next question. Why are short pitch windings preferred in alternators despite their lower induced EMF per coil? So they have already given it is the disadvantage. They have given lower induced EMF. And what are the advantages? We are preferring those. Why? What are the advantage? Short pitch in the sense less copper will be somewhat of saved. So less copper in the sense the losses will be less. Okay. So first of all, we can say copper losses will be somewhat of reduces. And the main important thing is nothing but it reduces the harmonics. Higher order harmonics are eliminated. So if it reduces the harmonics, the waveform will be uniform. You can get almost uniform waveform. So that means here you can say waveform is uniform, losses are reduces. That means you can say efficiency will be increases, correct? Efficiency will be increases. So it increases the overall efficiency. But what is the disadvantage? Due to the short pitch coil, somewhat of we need to sacrifice the induced EMF. Induced EMF will be reduces. In star delta starter used for induction motor, the starting torque is reduced to approximately dash. Reduced to approximately dash. A very easy question it is. We know starting torque in case of star connection, in case of star connection, 1/3 of delta. 1/3 of delta. So in this case, why we go with the star delta starter? So whenever it is converted, that is 1/3 of the torque, 1/3 of the torque. So it will becomes reduced to 1/3 in the sense 33%, 33% of the full load torque. Coming to the next question, microwave heating is based on which principle? Microwave heating. So in the microwave heating, we are heating the dielectric particles, that is nothing but dielectric heating. Simply, which of the following is key characteristic of slip ring induction motor? We know very well what is the main important thing of slip ring induction motor. Here we can add external resistance, correct? External resistance we can easily add. Okay, but in spiral case we may not add. We know very well starting torque is proportional to external resistance. As we can add external resistance means higher starting torque. Higher starting torque. Whenever the resistance increases, what will happen? Current, starting current will be reduced. So what are the main properties? Starting torque is high and starting current is low. So both are advantages. That's why whenever we require high starting torque, we go with simply slip ring induction motors. Okay. Coming to the next one. A basic theory question. What is the primary purpose of estimation and costing in the unit earthing for commercial installations? Why we require the estimation costing? So that is due to this estimation costing, we know we can get the idea which materials we require and what is the labor and what is the cost of the material. All we can know. So that is to determine the materials, labor and cost required for a safe and effective earthing system. Okay. Consider a fixed bias circuit using a NPN BJT transistor in CE configuration along with base resistance RB, collector resistance RC and supply voltage VCC. If beta is the current gain of the BJT, then stability factor of the fixed bias. A very easy question, guys. Question seems to be very big, but answer is very small. We know very well the stability factor in fixed bias. In fixed bias, 1 plus beta, that means as the it is mainly depends, stability factor is depends upon the beta. Okay, so simply you can say it is directly proportional to beta. You can say like that. The beta increases, stability factor value will be high. So it is directly proportional to the beta. Okay, very easy question. What is the primary purpose of interturn fault protection in an alternator? Interturn fault protection in an alternator. So, what is the main or primary purpose of interturn fault protection? To detect the faults between the adjacent turns. Okay, interturn means between one turn and another turn. Okay, so that is adjacent turns. So to detect the faults between adjacent turns of the stator winding. Very easy question. The direction of induced EMF in a coil may be found with the help of dash. Induced EMF, it is nothing but in generator, na? Generator. R. So here R is dominated in the sense, you can say Fleming's right hand rule. Okay, that is a simple trick to remember. In case of motor, in motor, left hand rule. Fleming's left hand rule to detect the direction of rotation. Okay, here direction of motor rotation. That is output na. Here in the generator, the output is induced EMF. To detect the direction of EMF, we use Fleming's right hand rule. So answer is option A. Coming to the next one. In synchronous motor, if the load angle exceeds 90 degrees, then the motor will become dash. A very simple question. Whenever the delta is less than or equal to 90 degrees, it will be in the synchronism. Whenever this load angle is greater than 90 degrees, then it may last synchronism. Na? It may last synchronism. It may last synchronism and will become stop. So answer is last synchronism. What is the role of heliostats in a power tower system? Power tower system. Okay, so heliostats are nothing but I think that is you have seen that is nothing but solar plates. Solar plates. These solar plates generally called as heliostats. Okay, so here these are tracks the sun direction. Okay, that is that is can say they are trying to fall the sunlight on their panels. Okay, so that means to track the sun and direct sunlight to the receiver. Okay, for that purpose we are using heliostats. What law explains the induction of eddy currents in armature? Induction of eddy currents in the armature. We know very well eddy currents in the nothing but we can say circulating currents. Circulating currents. How the circulating currents will be formed? That is due to changing of magnetic field. Whenever there is a change in the magnetic field, automatically an EMF will be induced. Due to that EMF, there is a current will be flows. That is nothing but we can say eddy currents. Correct? So here, whatever it may be, the voltage produced or current is flowing. The main reason is nothing but Faraday's laws, na? Faraday's laws of electromagnetic induction. Okay. So whenever there is a change in magnetic field, E is equal to minus N d phi by dt. Okay, whenever there is a change in magnetic field, an EMF will be induced. Whenever the circuit is closed, the current is flowing. Okay, the current is flowing. That is given by Faraday's law, God of electrical engineering, Faraday. In an auto transformer, if the voltage ratio is 2:1 given, what is the ratio of primary current to secondary current? What about the current? In the transformer, simply power is equal to constant. That is voltage into current is equal to constant. If you want current ratio, that is inversely proportional to voltage, na? So current will become 1:2. Then only power is constant. Correct? A very easy question. So answer is option 2. What is the purpose of 100% stator earth fault protection in an alternator? 100% stator earth fault protection in an alternator. So why we use what is the purpose of earth fault protection? To detect and protect against the earth faults. As the question itself, we have the answer. Okay. to protect against earthfalls occurring anywhere in the stator winding. So the answer is option 2. Answer is option 2. Okay. Okay, students, we will discuss the remaining questions in the next session. And students, if you like my classes, try to follow each and every one, every session. Okay. And please share to all your friends. If you still not subscribe this channel, please click on subscribe button. And you can also get the PDF by visit the sunnilengineeringacademy.com. Okay, if you visit this one, then you can get the PDF. Okay. Okay, students, all of you, thank you so much for watching. Take care. Bye, guys.